So I decided that instead of doing the example that I initially planned to do, instead of doing this one, I'm going to cross it out to change the basis of a matrix. I'm going to do the example which I wrote here in detail. Yeah. So in the last video, I just said that matrix M prime is 1/2, 1/2, 1/2, 1/2. So let me walk over this, okay? So first, let me copy all of this to the bottom here. So let's consider we have a transformation which is the projection into the x-axis. And this transformation is given in the x hat, y hat basis. It is given by the matrix 1, 0, 0, 0, okay? This corresponds to projection into the x-axis. But now let's say that we want to change the basis of this matrix. So the question would be change basis of matrix 1, 0, 0, 0 to a new basis. And the new basis is going to be B1 and B2, where B1 is x hat plus y hat and B2 is x hat minus y hat. So let me write that down. B1, B2, where B1 is equal to x hat plus y hat and B2 is equal to x hat minus y hat. Okay, so how do we solve this? Well, we need to find M prime, and M prime is given by the similarity transformations. So M prime is inverse of A times M times A. Okay, now M we know, but what about A, the change of basis matrix? Well, we need to remember how the change of basis matrix was built. So if we go back to change of basis chapter, remember that the change of basis matrix is simply writing as its columns the vectors of the new basis, but writing those vectors in the basis in the old basis, which for us is x hat y hat. Okay, so we need to write B1 and B2. We need to write B1 and B2 in the old basis, which is x hat and y hat. So what is B1, which is equal to x hat plus y hat? What is it written in the old basis, x hat, y hat? It's 1, 1. Yeah? In the old basis, x hat and y hat. Now, what is vector B2, the second vector of the new basis? This is x hat minus y hat. So what is it written as a column vector in the old basis? It is 1 minus 1, also in the old basis. Okay? Therefore, the change of basis matrix is given by these two columns written in the old basis. So first column is 1, 1, and second column is 1 minus 1. Perfect, we have matrix A. Now, the inverse of A, we know this is equal to 1 divided by the determinant of A multiplied by D and A minus B minus C. This is the recipe for the inverse, okay? And the determinant here is 1 times minus 1, that's minus 1, minus 1 times 1, which is 1. So we have minus 1 minus 1, the determinant is minus 2. And then we do dA minus B minus C. So the inverse of A is equal to the matrix 1/2, 1/2, 1/2, and minus 1/2. Okay, this is the inverse of A. So now we have all of the ingredients to change the basis of our matrix. We have A, we have the inverse, and we have M. So we just have to do this multiplication of three matrices. So let's do it. M prime is equal to inverse of A times M times A, which is equal to 1/2, 1/2, 1/2 minus 1/2 times M times A, which is 1, 1, 1 minus 1. So doing this product of matrices, we arrive at 1/2, 1/2, 1/2, 1/2, which is equal to M prime. Okay, So we have changed the basis of this matrix. Now, I mean, I did this product very fast because I already had the answer, but you know how to do the product of these two matrices, and whatever is the result, you then multiply it by this matrix. Yeah. Okay, so now the question asks, check that the determinant and the trace stay the same. So indeed, the determinant of M is equal to 0, and the determinant of M prime is also equal to 0, because, yeah. And the trace of M is the sum of the elements of the diagonal, so it's 1 plus 0, it's 1, and the trace of M prime is a half plus a half is also 1. So indeed, the determinant and the trace have remained the same. Okay? So this is a very clear example. If you want to see another example, go and see problem 3 in the notes, which was the original one I had written here. Okay? Thanks for watching.